Hello guys, good afternoon. You are welcome to my YouTube channel, the SPC Tutorials. As you all know, my name is Tutor Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, shall be discussing limiting and excess reagents in stoichiometry, which happens to be one of the subtopics under stoichiometry. In our previous class, we did establish the fact that stoichiometry is that branch of chemistry that deals with the quantity of substances used in a chemical reaction. We went as far as solving crucial questions regarding stoichiometry. So today we shall be discussing or solving questions on limiting and excess reagent. What is a limiting reagent? Limiting reagent is a reactant that is first used up in a chemical reaction. I can say that limiting reagents are reactants that are first used up in a chemical reaction. When reactants are used up in a chemical reaction, it therefore means that there will be no formation of what? Product. Product will not be formed because the reactants have your what? Used up. What about excess reagent? Excess reagents are actually reactants whose quantity exceed that of what? The limiting reagents, which means that because of the fact that it is excess, it means that product will be formed, unlike limited reagents that does not result to formation of what? Product. We are not here to talk story. We are here to focus on questions, how questions can be tackled with ease. Now you have one of them on the board. As time goes on, shall be solving more questions. Okay, says iron metal can be produced by the action of carbon monoxide on iron 3 oxide according to the equation. You have it. What is the maximum amount of iron which could be produced by the reaction of 120 gram of iron 3 oxide and 120 gram of what? Carbon monoxide. It is very simple. Since we've practiced some methods of answering questions on stoichiometry, we established that number of moles is equals what? Mass over what? Molar mass. All right, mass over what? Molar mass. What is the maximum amount of iron which could be produced by the reaction of 120 gram of this and this? All right, so they said iron metal. Look at the first word here. Now we are given the mass of the first entity, which is this, to be 120. Okay, then for we to calculate, okay, it therefore means that mass is 120 over molar mass. For we to solve for the molar mass, we have Fe2O3. In doing that, it's going to be done like this. Iron has atomic mass as 55.8. So this is 55.8 times 2 point what? Plus 48. I believe we all know how I got 48, because oxygen is 60. 60 times 3 is what? 48. So let's add everything together. I'll be having 55.8 times 2 equals then plus 48. I'll be having 159.6. 159.6. That is the molar mass of what? Iron 3 oxide. Which means that number of moles is equals 120 divided by 159.6. I'll have 0.75 moles. 0.75 what? Moles. Now from the reaction, it means that 1 mole of this guy will produce 2 moles of iron. So 1 mole of this will produce what? 2 moles of Fe. Alright. Secondly, it means that 0.75 moles of this will produce what mole? You say 0.75 mole of Fe2O3 will produce what? X mole. If you should cross multiply, you'll be having x mole equals this times this, that is 0.75 times 2. I'll have 1.5 mole. 1.5 mole. And I have 1.5 mole of Fe2O3. Is that not correct? Very, very correct. Because this times this is 1.5 divided by this, the same thing, it does not change. That is for that. So what I've just done is to look for the mole of this first entity. Now the second one here is 120 gram of what? Carbon monoxide or carbon 2 oxide, as the case may be. The same approach is actually needed here. So number of moles is equals to mass over molar mass. Mass from the question is 120. The molar mass of carbon 2 oxide is simply 28, because 12 plus 16, you have what? 28. So which means 120 divided by 28, I'll have 4.29 approximately, 4.29 mole approximately. Is that the final answer? No. That is not the final answer. So we have to keep solving. Oh, I've rubbed up the equation. Oh God. Okay, no problem, no problem. Then from here, it means that I was seeing the reaction now. Fe2O3 plus 3O will give 2Fe plus carbon 4 oxide. From this place, it means that 3 mole of CO will produce 2 mole of what? Fe. Is that not correct? Therefore, this 4.29 moles of CO will produce X mole of that. So what do we do next? We cross multiply and divide. It means that X mole is equals this times this divided by this as usual. So 4.29 times 2 equals 8.58 divided by 3. You have 2.86 mole. 2.86 mole of Fe2O3. Now, what this one is from carbon 4 oxide. Where is it? Okay, of Fe. Sorry, Fe. Now, looking at what we have here, in the first case we had 1.5 mole of Fe, and in the second instance we had 2.86 mole of Fe. All right. Now, from what we have done so far, looking at it properly, you will observe that where is it again? You observe that iron 3 oxide produced the smaller amount of what? Fe, which is what? 1.5. Iron 3 oxide produced a smaller amount of what? Fe. You have what? 1.5 mole. But as for carbon 2 oxide or carbon monoxide, it produced what? 2.86 mole of what? Fe. From what we have done so far, so which of them is the limiting reagent? Which of them produced the smaller amount of what? Ion. The answer is what? FeO3. It therefore means that the limiting reagents in this reaction is what? Iron 3 oxide, because it produced the smallest amount of what? Ion. Hope that is understood. Now, you have what is the maximum amount of ion which could be produced by whatever. Good. the maximum. I think they're also asking us the mass of, okay. Oh, okay, I think we've done for this. So to calculate for mass now, I don't know if I can rub it off. Okay, I think I'll use the textbook here. I'll use it. Let me rub off this part. Calculating for the mass of Fe, I know that the atomic mass of Fe, okay, to calculate the mass of Fe, this is how it's going to be done. Listen very well. The molar mass of Fe is simply what? 55.8 gram. Is that not correct? The molar mass of Fe is what? 55.8 gram. But to calculate the mass in terms of limiting and excess reagent, you don't leave the answer to be what? 55.8. What you need to do is this. We got the limiting reagent as what? 1 as this, which happens to be 1.5. Therefore, the molar mass, the mass becomes 55.8 times 1.5. All right, 55.8 times 1.5 equals, you have it to be 83.7 what? Gram. That is for that. Now B says, what is the excess reagent? What is the excess reagent? Is it reagent? Okay, reactant. What is the excess reactant or reagent, as the case may be? And how much of it would be left over after producing the maximum amount of what? Fe. After producing the maximum amount of Fe, which we just got 83.7 gram. B, we've solved for A. Said, what is the excess reactant? And how much of it would be left over after producing the maximum amount of what? Fe. Now, this is what we are going to do in looking for the excess amounts. So I'll rub off these parts. Is there any? Okay, now, using this reaction, we've established the fact that CO is the excess what? Reagent. Is the excess reagent. While this guy is what? The limiting reagent. Now, what is the molar mass of carbon 2 oxide? It is what? 28 gram. So 28 gram of carbon 2 oxide will produce what? Will produce 55.8 gram of what? Ion. Is that not correct? It means that S gram of CO will produce 83.7 gram of what? All right, of what? Fe, which means that the excess reagents we said is this, right? Where is it? Carbon 2 oxide. In looking for the excess reagents, of course, you have to look for the one that is remained. Or how they put the question again? What is the excess reactant? Is that what is the excess reactant? The excess reactant is what? CO. How much of it will be left over after producing the maximum amount? So from here, you can now cross multiply and do whatever you have to do. So this times this, that is, you are going to cross multiply. So 83 times 83 83.7 times 28 equals, okay, I'll rub off this part, please. Let me bring it down. I'll have 83.7 times 28. I'm having it to be 2343.6 divided by 55.8 divided by 55.8 equals, I have it to be x small equals what? Yes, okay, x gram, sorry. X gram, not x small now. S gram. S gram becomes 42 gram. 42 gram. Now, for you to know the one that is left over, the leftover one is simply the difference between the SS and the initial. The SS and the initial from the question given. Like that, you now have S, that is S gram, that is 42 gram of what? CO. Don't forget. Now, for you to now look for the reactants or what is left over, what do we need to do? It is simply the difference between the SS reactants and the initial what value given from the question. I think they gave us 42, right? Is it 40? Okay, no, not 42, sorry. 120. It should be 120. So yeah, 120. Therefore, S gram is equals 120 minus 42. And now that 120 minus 42 equals 78. So S gram is equals what? 78 gram. All right. So that is the final answer. I believe what I've said so far has been comprehended. If there's anything you want me to do, just drop it on the comment section. So let's take another question, please. Let's take another question. It is very, very easy. Just follow it bit by bit. You would understand it. All right. Hope it's recording. Oh, yes, it is. Okay. I have a question here. Using, okay, no, that's not it. That's not it. Okay, said urea. They said urea, which has the, let me write it very short. Urea, NH3. Is that, wait. Okay, sorry. NH2CO is prepared by reacting ammonia with carbon 4 oxide, right? Yeah, carbon 4 oxide or carbon dioxide. As given here, it said 2NH3 plus carbon 4 oxide. This will produce NH2CO plus what? Water. Plus water. Yes, that is what this urea produced when ammonia was reacted with what? Carbon 4 oxide. Carbon 4 oxide. Now they said in one process, 637.2 gram of ammonia are treated with 1142 gram of CO2. Now here comes the question. Which of the two reactants is the limiting reagent? I know you can solve it. So what do we do next? As usual, number of moles. Oh, I think I have to change this marker. Number of moles is equals what? Mass over molar mass. The question, they've given us the mass as 63.7.2 divided by the molar mass of ammonia. N is 14. 14 plus 3 is what? 17. So I have what? 17. So let's divide. 637.2 divided by 17 equals 37.4 mole. Alright, 37.4. Let me just make it two decimal places. 48 mole. 48 what? Mole. Then from here, we can now we can continue. It's written already, but I cannot pause it. Don't worry, you hear me clearly. Now what do you do next? From this reaction, it means that 2 mole of ammonia will give 1 mole of urea, which is what I have here. Then it means that 37.48 mole of NH3 will produce what? X mole of this, of a mole of urea. So let's multiply and divide. So this times this is written as this, then divided by this. So X mole is equals 37.48 divided by 2 equals 18.74 mole. 18.74 mole of urea. So which means that from the reaction, it means that ammonia produced 18.74 mole of what? Urea. Then that is for ammonia. Let's now solve for what? Carbon 4 oxide. Number of moles is equals mass over molar mass. The mass from the equation is what? 1142 divided by the molar mass. What is the molar mass of carbon 4 oxide? That should be 48, because 16 times 2 is 32 plus 12. That is 44 rather. You have 44. It means 1142 divided by 44 equals 25.95 mole. Is that the final answer? No, that is not the final answer. It therefore means that 1 mole of this, 1 mole of CO2 will produce 1 mole of urea, which is this very idiot, alright? Then 25.95 mole will produce 1 mole. We produce, X mole of urea. So what do we do next? Cross multiply and divide. So X mole becomes 25.95 times 1 divided by 1 is the same thing as what? 25.95 mole of what? A mole of urea. Now from what we have solved so far, alright, we had the first one to be 18.7, that is ammonia produced 18.74 mole of what? Urea. Then carbon 4 oxide produced 25.95 mole of urea. So which of them is, they said, which of them between ammonia and carbon 4 oxide which of them is the limiting reagent? Very easy. The limiting reagent, of course, I know you know it. The answer is what? Ammonia. It is ammonia because it produced the smallest amount of what? Urea, which is what? 18.7 mole. Okay? Now, what is B? He said calculate the mass of urea. I believe you can solve this. Don't forget the hints I gave us before, or the initial question we solved. Alright? So, to calculate for the mass, of course, the molar mass of urea, we have NH3, 2, then CO. How do we solve for this? Nitrogen is 14, right? So 14 times 2 is what? 28 plus hydrogen is 2. 2 times 2 we have 4 plus then carbon is 12. 12 plus 16 you have what? 28. So what are we going to have? 28 plus 4 plus 28 equals 60. So which means that the molar mass of urea is what? 60 grams. 60 grams. Now for the mass of a mole of urea, I told you multiply this with the limiting reagent. That is the limiting value we had, which is to say 18.74 times 60 equals 1124.4 grams. That is the answer. Very, very easy. Just follow it step by step. You understand it. The last one here says how much excess reagents is left at the end of the reaction? How much excess reagents is left at the end of the reaction? Just as we solved initially, you know what to do. So from the reaction, alright, this is carbon 4 oxide. Carbon 4 oxide has they said in gram. Carbon 4 oxide, the molar mass of carbon 4 oxide is what? 44 gram. It means that 44 gram of CO will produce what? 60. Is it 60 now? Yeah. 60 gram of urea. Alright. Yes, of course, the excess reagent is definitely carbon 4 oxide. It means that S gram of the excess reagent now will give what? Will give 1124.4 gram. 1124.4 gram. So, you know what to do now. You know how it goes. Very cocoa now. So it means that 1124.4 times 44 equals. So it means that S gram is equals 494.6 divided by 60. So divided by 60 equals. So S gram is equals 824.56 gram of what? CO2. You see, it is very, very easy. Now, how do we know the amount of reactant remaining or that is left over? I told you it is this value, it is difference between this value and the one given from, okay, in the question. Therefore, S gram is equals carbon 4 oxide. What were we given as 1000? So 1142 minus 82 4.56. So 1142 minus 82 4.56 6 equals, so S gram is equals what? 317.44 grams. So this is the final answer. This is what? The final answer. Just follow it step by step. You will understand it better. Alright, take this one as your personal assignment. So I believe what I've said so far has been assimilated. So let me put the next question on the board that you are to solve yourself. Alright, do it as your personal assignment and drop the answer on the comment section. It is very, very important. They said the reaction between aluminium and iron 3 oxide can generate temperature approaching 300 degrees Celsius, and it is used in welding metals. The reaction is expressed as 2 aluminium plus Fe2O3 to give Al2O3 plus what? 2Fe. This now okay, let's say in one process 124 gram of aluminium are reacted with 601 gram of Fe2O3, right? Now here comes the question A. Calculate the mass. Calculate the mass in gram. Calculate the mass in gram of aluminium oxide form. Alright. Then B says how much of the excess reagents? Alright, how much of the excess reagents? How much of the excess reagents is left at the end of the reaction? Alright, so at this point to call it a day. Thanks for watching. Do have a wonderful day. Please endeavor to subscribe.